Right, so welcome to RoboCup online class. So we are now the start. So just now I introduced this speech recognition. Okay, synthesis in the first half. So if just in case you just joined us, you can see the replay later on about how to make your robot say something, right? So you can give the text and you can write this thing in the Python code that can do this thing automatically. Then the next section is I will share with you how to do simple recognition. So speech recognition can be very complicated system, can be very. I will show you how we can do it in a very simple way. Okay. So the first thing is just a definition, right? So speech recognition is a process to extract speech content from human's voice. So we say something in natural, then it will record down our voice or speech in waveform or in. So then it from this process, or what is the content of what you just said, right? And normally it also we also call it like an automatic speech recognition ASR. So maybe you come across this keyword quite frequently in speech recognition. This automatic speech recognition ASR short form. So it converts spoken words into. Now we have text, then we convert to speech. Now we want to convert back speech into text, right? And a general, okay, it might have a lot of way, but a general way is like we have a. So if you look at the diagram, so we have the waveform is a signal. Then once we record into our system, we will do analysis on the signal. So you might know a lot about signal processing. So this is one of the process. So we do features extraction. Okay, features extraction. So how to do this feature extraction? Okay, we segment it into some way that we can do recognition later. And recognition is like pattern matching. Okay, so you can see like we actually have a template library for certain default wave pattern or signal pattern for certain, which means something else, which means something in specific, for example, like certain words and so on. So we know how the waveform look like, right, or the signal look like for certain words or pronunciation, right? So we train that thing. We actually do the pattern matching. Okay, so we have the signal as an input, then we compare to our template that we use a lot of pattern matching algorithm to do the pattern matching. Then we will decide whether it is similar to which words or how confident, what is the confidence level and so on. So basically this is the general idea how the speech recognition works. But of course, this is not the only way. They might have a lot of way, and particularly now we have the deep learning stuff and so on. So yeah, this whole process can be very complicated. But yes, we can actually study a lot on this speech recognition algorithm. Okay, right. But over here, today our discussion is again more focused on the development. So how to make your machine able to recognize some words or some sentences that you want. Okay, right. So now let me introduce the tools that I'm going to use it, which means this speech recognition can work without connect to cloud resources. Okay, which is it is very light, very small, and it can run on small machine. And the tools that. So you can head to the website of CMU Spin. Knowing is in this CMU Spin, they actually have various tools, right? So just in case that you cannot find or you found a lot, you overwhelmed with the information, we are actually using one of the module in CMU Spin, module in Spin or this CMU Spin system to run on mobile machine. Okay, so for example, like our laptop with very on your, for example, your phone, right, with very small space and also resources, and processing is also the computing power is not high, so it is designed to run on small machine. Okay, so it's very light and portable, but we need to have a big template library, and we need to do a lot of pattern matching, we need to do a lot of processing and so on. So how to keep all this calculation and resources small? This CMU Spin, they do a lot of work to like optimize a lot of processors and also the database in order to make this speech recognition able to run on very small machine. Right, and it's also can run on like normal laptops that we have it now. We have the trade-off, like if you want very little resources, very small system to run, and everything is offline, so with all your onboard resources to run this very big system, we will trade off a lot. Okay, for example, like for speech recognition offline on a finite database. A finite database means, okay, so this is a very big difference for offline and online. Finite database means you only train the system able to recognize those words that you intended, okay, those words that you intended for the machine base, okay. So, and this is good if you just want simple instruction. For example, you want to build a machine, play a song or something like switch on and off your curtain, and all these very simple instruction that you have a finite list of instruction you want the machine to know, and you want to do this very efficient way, which means you want your machine to just recognize these few commands, which means it won't waste a lot of time to do the pattern matching with whatever input with a very big database. Because if you want the robot to be able to listen to you and understand anything you say, so that one is very hard to do using this offline system. Okay, but the offline system is more designed specifically for the task that you want the machine to recognize very specific instruction, right? Like what I said just now, like turn on the light, switch on the whatever things that you want and so on, which is you already like have the idea and you can list down all the information. Oh, sorry, all the offline speech recognition will work much better than your online speech recognition system because it won't waste a lot of resources and time in order to process for an open-ended conversation. Okay, right. So this usually we use this offline speech recognition for very specific to tally all our robots. Front, move back, turn left, turn right, and so on. Or some simple instruction like go to kitchen, move to kitchen, find me something, go to this person, and so on. Which is we can have some finite combination of all the words that we want in order to assemble into some variation of the instruction. Okay, so we will show you this. But of course, you also want a speech and everything you want to say, and that I would recommend you might want to use the online version of speech recognition, things that have a big database and also big computing power in order to all the sentences that you might say that maybe before that the designer don't know what you're going to say. Okay, right. So again, I explained a bit length have the correct expectation because sometimes students come to me that say that this offline speech recognition is not accurate or is not acceptable for. So if you want to do this kind of things, maybe you want to do the online version and so on. And one tips that I will say, okay, later on I might say a longer one, is like this offline recognition is actually good for wake up phrase. For example, okay Google. Mostly, almost all the speech recognition products is wake up phrase. For example, okay Google and so on, right? Series and so on, right? So it is good to use this offline speech recognition for this wake up phrase. Why? I will explain more later. Okay, so let's now start with the speech recognition install. And this installation might be quite low internet connection. Your download speed is not so high. Yeah, you might so one by one all these things. And to install this Pocket Spring, you need the PIP Python. So we install it using the Python way, using this one open source example by this person. So we install the example and then we make how to say steps is to add the language model, right? So please download this language model from this site, and you need to untar, which is unzip. Okay, so it is a compressed folder. You copy the content, not the file itself, but copy the content, not the put in the compress into the folder. It's not, you need to unzip. Okay, but over here it is not a zip file, it is a tar file. So you need to untar it and this folder. And just for your information, this folder may not exist. So you need to like sudo, okay, because this user is not within your home directory. So you need to use sudo mkdir put recursive folder. And you need to build this thing and then copy the content into this folder, right? So this, and if you are not clear, yeah, you can ask me after the session. I will show you in a more graphical way. Okay? I might show you the thing, okay, where's the folder and so on. Right. So this step, just be careful and make sure that you have the language model installed. Right, good. So let's start with a demonstration. Okay, so for the demonstration, I actually have two examples. Okay, one is the KWX example, which is I took directly from this pocket, or the keyword spotting mode. Keyword spotting mode. Yeah, keyword spotting mode. Okay, but I don't use it a lot for this. It's because like in order to produce the database is quite troublesome, and also this keyword spotting mode is more towards the usage is more towards like you have a passage, you have word from the passage and so on. Okay, which is less useful for our application, but you can try it. Okay, so let me show you this example. Right. So okay, again, I need to like put this thing down. Okay, I need to wait. Sorry, I need to make this thing. The whole thing is not too small. Okay, so and the whole thing is not too small. Let me clear up my terminal. And this one. So first thing is before you start anything, you need to see because the keyword or what are the database. Okay, use other thing. Okay, I normally I use less. And this for this example is also is inside this Pocket Spring folder. Demo. Then we have this voice, which is they call it the DIC, the dictionary. Right. So you can see we only have this keyword: back, forward, full, half, left, move, right, speed, stop. So the system. So this example only trained the system to recognize these few words. Simple as that. And behind is actually the pronunciation. Okay. So okay, being Asian, so I might don't have a very good English pronunciation, so sometimes it fails. Okay, we read this word, we call it stop, which is with the O, right? But apparently the American way, which is I'm not sure whether true or not, maybe someone in our community can enlighten me. So the pronunciation is actually stop, STAAP, stop. I don't know. That's the American way. So apparently, like this Pocket Spring, the language model that we install, everything is follow the US English pronunciation or system. Okay. So if you are not native speaker and you don't pronounce in the US English way, so the recognition might be not working very good. Okay. But of course, we can actually like find the British way of pronunciation. But somehow I don't pronounce like the British way as well. So yeah. So sometimes when we have this slang and solution, but yeah, you can refer to the dictionary on how to pronounce it in the way that the machine can understand, because that is how you build the database. But what I can say is like there are, okay, so if you head to CMU Spin, they actually have a module to train the system in order to adapt to your slang. Okay, but that is a whole new topic to talk about. Okay, because you need a training process to actually make the system adapt to your pronunciation and so on. But that actually not advisable if you want to build your machine to work with anyone, because everyone speaks differently, right? So it is not easy for the machine to understand. If you make the machine adapt to your slang and nobody actually speak in your way of pronunciation, then your recognition is not going to work nicely with a lot of people. Okay, so the default way is like they will use the standard pronunciation to build the thing. So you can see this standard because like it follow the US English way, but you can select or you can find the appropriate language model in order to suit your audience. Of course, it's not easy. I can say, for example, like for me, I have previously lecturers from all over the world. So all lecturers actually speak very differently based on their local slang and so on. So sometimes I also don't understand. And or same thing to speech recognition system. They also have this kind of slang problem. So maybe you need to be careful on this. So not always is the recognizer problem. Okay, the problems can lie on many other things. Your mic, your input, your anything, and included your language model that whether it suit your pronunciation or not. Right. So these are a lot of things, a lot of challenges to make your speech recognition work well with your community. Okay, right. So yeah, so so let's investigate like database. Okay, so the first thing is I need to run the example, which is this KWS launch long command. So we have the launch file, two very long argument dictionary. Okay, so you need to define. So in order to use this KWS, which is the keyword spotting, where is your dictionary file, which is this database dictionary file, your keyword list, which is the energy or the definition of the keyword over here. So you need to define this too, which is quite tedious to type everything. We can simplify this, but first we start with the very basic thing, like you type in the launch file and then followed by all the argument that you need. Okay, practice that you try. Okay, so you need to replace the username to your computer name. I mean like computer username, and it's advisable to use the tab. Okay, for autocomplete. So this is to check to make sure you type everything correctly. Okay, because any miss in spelling will make the system will not able to find your file and so on. Okay, then we have the KWS home install caption source. Okay, but I want you to go through this process. It actually rely on your specific dictionary and keyword list file in order for it to work, which is previously you don't have this kind of argument. So I made you type this as a practice, but of course later I will show you how to actually define this in the launch file. Voice key. Okay, done. So if everything is okay, so okay, everything is fine. Then in order to show the result, so the result of the reckoning name KWS underscore data, right? So raw topic echoes or type out, I'll print out the result. Okay, so you can see like now, okay, you see by saying random, so how to, so this is very normal, okay? So it is very normal to have false recognition, okay? But you need to overcome this with not just, so let me show you what are the things that you can do to overcome this. So the first thing is, again, check your mic setting. So this, and then you select, you can see I got so many B1 is because like I ran out of battery for my microphone. So but you can you need to select the mic amplify, which means how many gain you want to set will receive your voice, okay, and convert into signal, electrical signal, gain to amplify, because the signal that received from the for the sound card to do the processing, right? Okay, so how critical step over here, but it is not always the best idea to into the might also contain noise. The keyword is the signal to signal to noise ratio. Okay, so which means noise and your signal. So for those students that things to handle, so all you want to card and to all the process that you handle and maximize the signal. So you want the signal to be much is very challenging, especially when you are outdoor or in a very noisy environment. You have your kids screaming, you have your house appliances make noise in background that will cause you a lot of noise, and then the speech that you say. So in that case, your noise, and then you put your gain very high. For example, like you put like 100% and so on. You can see the command or the instruction that I want the robot to know. I actually receive a recognition. Okay, so this is unavoidable, but I will say you might want to adjust this based on your working by reducing the amplification. Okay, so when I don't say anything, something like this. Okay, oh, okay, so this one, you see when I say something, then it pick up, but I'm not saying anything about the command that I want. Okay, so maybe it's quite stable, but we just keep it to make sure that we can adjust again. We can do. Then okay, let me try. Okay, so I clear this again. Okay, after I adjust this, I try again. Okay, forward, left, right. Can you see? It's not really good. Move, left, stop. Not really good. And see, the recognition is actually not very accurate. Okay, like our database, especially for this keyword spotting, is like detecting very short words, which is you only have one pronunciation. I mean, like back and front and be close to each other, which is make the recognition accuracy. I seldom use this keyword spotting mode. Okay, in this case. But well, okay, so this is one of the things that you can play around the mic to adjust the accuracy, to adjust your database and so on, right? In order to do this. Okay, but just for example, okay, but I don't know like how come it's so bad. It's like if you are interested to, for example, this is back, right, and move and so. This example, I just want to show you the example how it is done. Okay, because later on I will use the LM mode, which is a better one for the recognition. Can use it better, right, in my application. It's like I can connect this to my robot to show you how you can channel this command to know how it is connected. It is actually just flow the topic from this, okay, into the robots. Okay, and also I have another example that to show you how the word and do some response with the word that you recognize. Okay, and this example is very important for your assignment. Okay, so I will come back to this have a comparison between the keyword spotting mode and the LM. So I will come right. So let me stop this and okay, for the LM mode, I feel that so just to show you as a comparison first, much longer. So the first thing I want to do is like I show you this one also it require a database. RC home ROS. Okay, now I'm using the sorry. Okay, I'm using example, but I'm using the example that I written that I gave you. Okay, so over here we have a RoboCup, and this RoboCup. Okay, we have a file for the corpus. Okay, so let me show you the corpus. So these are input, or these are the words that I put into my database, and you can see like they actually form sentences. Is Elizabeth, and bring me the chips, or bring me the beer, or bring me the lemonade, Milo, and so on. And Milo, I actually not so sure what is the correct pronunciation in US English. Right, then we have the follow me, thank you, and stuff, and go to, and you can see it's much bigger database, and then in sentences. Okay, but recognize a sentence or a bunch of keywords, the recognizer become much accurate because false detection become lower. Okay, so you need to understand the accuracy of the recognizer come into a balance between these two. You want the accuracy, the recognizer to be high detection rate or high accuracy. Okay, so you need to balance between these two. High detection rate means it can, right? But if you move your confidence level to be very high, you might have very high accuracy, but your detection rate might be very low. Either way is not good. Okay, if you have high detection rate, but your accuracy is very low, you have a lot of false recognition, which is not good because it hears something but it hears wrongly. But if you have very low detection rate, although your accuracy very right, so how to balance these two is something that you need to adjust your system to make sure that you have very comfortable detection rate, which is acceptable, and also very comfortable accuracy, right? And also you can have a lot of mechanism to help this process without relying totally on the recognizer. For example, even in human being, when we hear something from your friend, for example, sometimes you'll say like, "Excuse me, please repeat what you just said," or you might say something, or "Do you want this?" and so on. So these are all the strategy in terms of logic in order to help you, because we want to have the detection rate as high as possible, but we don't want to have to make, I mean, like, we don't want to accept all the detection as it is, because sometimes when the detection rate is very high, but the confidence level is very low, you might want to do some strategy. For example, like asking back the user, asking back to repeat, and so on. Damage done to your system by having or by accepting the false recognition. So these are the things that you can work out in order not totally dependent on your recognizer. Okay, and this is very important because your recognizer will never be 100%. Okay, and even in human beings, sometimes we hear wrongly, we hear not correctly as well. It happens in us as well. So for machine, you need to keep in mind on this. And a lot of things that you can play with, I mean, like adjust. A big database or a small database, a long sentence or a small short sentence, and so on. These are all the things that you have to adjust. And I don't have a standard or the best way for you. You have to try out and try to see how to make the best for the system, because always the best is to suit your design or your requirement in your application. Okay, right. But over here, I will advise you need to know how to choose the right tools and right strategy to maximize or to optimize your development. Okay, right. We built the database. So now let's us run. Okay, so I'm going to use this. Okay, so first it's like the package is some RC speech. Okay, and then this one is some LM. You need to define where is the dictionary. So source. Okay, so I need to wait from here. Source. Then where's the next thing? Where am I now? This one, right? Okay, the RC again, speech, and this time in the RoboCup folder and RoboCup.dic, right? Then the next argument is the LM, oh sorry, LM, and then start from me. Okay, where am I? Okay, here, this one, RC, speech, RoboCup, and .lm, oh sorry, RoboCup.lm. Right, okay, so I run the whole thing. Oops. Okay. Oh, it's not ls, it's lm. Yeah, need to be very careful with this intake. This reading is okay, so clear this, and I'm going to do this one, but this is lm data. Right, okay. Right, so I will start with this. So maybe I need to make my speaker less sensitive. Sorry, mic less sensitive for speaker. We use this further. Okay. Okay, let's try something. Okay. My name is Michael. Okay, at least it got the Michael. Okay, it got the Jessica. Right, then let's see other thing. Vicky. Oh, good. Okay, let's try. Bring me the conflicts. Okay, bring me the conflict. Okay, maybe my conflict pronunciation is not good. Okay, let's try this. Thank you. Good. Follow me. Okay, not bad. Can you see the accuracy is not that bad, and at least it can catch some keyword. So sometimes when you want to do the recognition of the sentence, you might no need to recognize the whole sentence in order to guess what is the meaning. yeah, I think it seems like human conversation as well. Sometimes you just hear the keyword as not the whole sentence, although it's quite dangerous to do that. But yeah, that's how we do things as well. This is the dining table. Not bad, got the dining table and so on. So you can see we can pick up some keyword quite accurately. Will be the system that I recommend you to use for your offline speech recognition work. Okay, so the next thing is I'm going to show you is actually how to create the database, because you might want to have your whole set of instructions that you want. Okay, so let's hit to this UI. You can understand it better. So the database is over here. So you just need to go to over here, the generated database. So how to generate the database is, first you need to create for this LM mode. First, you for every line you space, then you write the line again. So these are all the things that you want the robot to recognize. Okay. Close this, close this. So once you create a file, then what you need to do is then you go to this website. Okay. So this website is over here is a CM speech CMU, this one, and then this, I think it's testing. You will see this page. Okay, so this is the LM tools that help you to generate the appropriate LM and DIC file from your corpus file. So the corpus file is just with, once you created that, you just need to upload your corpus file here, then you style file that you can download. So you download the file and you will get the content. I mean the related replace, or you need to put this in somewhere that you are going to specify when you run your LM launch file as the argument. So where is your new dictionary file and where is your new LM file? Like at least you need this to the dictionary and also the LM language model file. Okay, so these are the two that you need to update after you generate new database for your speech recognition to work. Okay, then you will have this LM underscore data as your output that publish to this topic every time this record to this, and try to analyze this result and try to guess what is the, yeah. So the guessing part is the recognition in your coding, the machine here. Then from there you behave according to the input, right? Okay, so that you might say, okay, to specify is very troublesome. You use this. Okay, let me stop this. You can use. Okay, you key in the argument of this one, this two into the launch file. So how you do it? Okay, so first you go and edit the lm.launch. So you raw cd, you go to this speech and then launch. So inside here you can see there's a lm launch, and I already created the lm2 launch, which is the answer. So if you open up the lm launch, so let me do it dot launch. Okay, don't worry or don't overwhelm by all the input here. Okay, you just need to see that, okay, these are all the argument that I define. Okay, so inside this argument that you want to define, like inside there is a define this path, which is the language model and the dictionary file that you generated inside here. Okay, you just need to type inside here to specify in your launch file. Okay, but remember, after you specify, if you updated, for example, your language model and your dictionary file change place, for example, you move the folder and so on, you need to edit the edited version. I have no time to type it. So yeah, this LM2, this is the, so what I do is very simple, path into this DICT argument. I type it, I add it here, and for the LM, I just add it here. Then I save this file, or you can save it, and you will, sorry, okay, so you can see from this lengthy input element, so I just need to add that thing into your launch file, and I just launch this, and you get the same effect. Yeah, you get the same effect. Okay, so you can do that. But why I want to demonstrate here is two objectives. First is to make you know that you need to rely on your custom DIC and LM file in all the cases. The second thing is I show you this is how you can, okay, but well, you can get the same thing. Right, so let's finish this. Okay, I come to the end. So I will show you the assignment. I want you to practice to combine the speech synthesis that we learned today with the speech recognition module. So these are the two modules. You are going to combine them together to develop a robot speech question and answer system. So what you need is, like, after you run your system, the machine should be able to recognize what you say and try to answer your question. Okay, so you design and develop server question. Okay, so the question will be inputted will be the input for your speech recognition, and the system to do self-introduction. So you can design a few lines. For example, like the question will look like, "What is your name? Where are you from?" And so on. Okay, you can design. You can make your own story. So now try to think how you want to create the identity for your robots. Okay, name, what is your age, and so on. Okay, you can design to little. Okay, 5 or more. Okay, up to you. Then you need to do the possible question that you're going to ask, and then you are going to write the answer in your speech synthesis button. And then you are going to display the result not just by asking the robot to say out, but also you want to print it out, which is a raw file log. Okay, so if you have done this, you want to submit and everything, I'll recommend you to upload your source code, your system design. So what node you are using and what are the names and what are the question and answer pairs that you design. You can put it, you can write into a document, or you can write directly on GitHub using the .md file. Okay, then in order to show me or to show the rest of the people how your system works, you can by showing the terminal, and also you speak to your machine. Okay, taking your videos, then you will show like how the interaction work and how the mechanism work and so on. Yeah, you can put all these things into GitHub, and then we can discuss on all these things. All right. So that is the explanation of the assignment. Just now what I just left here. So the first thing is refer to this top button hints to show you how to do your assignment. Okay, so you go to this talkback.py. Back do is it actually already connect the recognition and the synthesis. So you already have the half of the answer over here. Okay, the sound play, okay, and also other stuff. So what this talkback do is it actually try to recognize. You see, it have this. This is a synthesis. What it does, it actually subscribe to this KWS data, right? So you put, although this is not a publish, but it okay. So let me go through this to show you how this thing is done. So this talkback, the purpose is the machine will listen. I subscribe to the output of KWS data, which is you need to run your KWS. So in your assignment, instead of using KWS, you are going to use your LM data, and you're going to build your new database for your LM data, which is the question. You will subscribe to your LM data so that you will get the result from the recognizer. So you will get the hints. You are going to do some logic over here that your whatever data, you are going to guess what to the say to I heard you say something and the answer is something. Okay, and I put the volume 0.01 here, which is very, very soft. If you run this talkback, you might misunderstood that the robot actually say nothing because the volume is very, very low. Okay, why I do this volume is because your mic and your speaker too near. If your mic and your speaker is facing to each other and you put your volume to 1, you are going to do a lot of echo, all right, and you will get a lot of noise. So I put this volume here to like let you select the volume that you want. You can put back to 1 as long as you have your mic and speaker in different directions, which means they don't interfere with each other. Okay, so this might don't give you a lot of hints how you want to do the logic. So let me show you another. Sorry, I need to go back here. Another activity. You go to the apps, for example, called. Okay, so this party bot actually, right? So you see the talkback is actually the callback for the subscription of the LM data, right? So then you compare. So if your input or your recognizer result have something called introduce yourself. Introduce myself, I am something, something, and something, 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 so on. So you can see this is actually the answer for your assignment. Okay, but I like introduce yourself, how are you, and so on, and phone and so on. Yeah. But this example first time because it's like quite long file, but actually it's nothing much complicated. You can see it actually different. So if it got the keyword like you, no matter what sentence you say, you might say, robot, can you please introduce yourself? Or you might say, introduce yourself, please, robot. Okay, as long as it can pick up the introduce yourself as keyword, it know like, okay, you want the robot to introduce yourself. So the robot will say Simon. Okay, right. So I have come to the end. And sorry, not this one. To add. Okay, wait, where is my this one? Right. Okay. But as this course is for fundamental, very basic service robot development, so I have pulled out the additional classes for speech recognition because for speech direction, because initially I actually, but next week I'm going to switch to visual perception, which is image processing and so on. I try to keep only the basic for this course is because like to know more about speech interaction or interested into speech recognition so that I can introduce other things. So there are actually, I actually have content languages support. Okay, for example, you don't want English, you want, for example, Chinese. So I have another module to show you how to do all these things in Chinese and other things. But of course, I don't have everything. But yeah, I can show you like how if you want to do this speech recognition and synthesis in other languages or in other language support. Okay, so I can have class on that, and also I can show you the way how to do the speech synthesis and recognition by using the online API. For example, you want to use a Google API, you want to use an Amazon API, you want to use Baidu API, and so on. So how to use all those API for your speech synthesis. So this sound detection localization, this one, unless you have the hardware, which is the microphone array, I can show you how, because our robot actually able to do this localization. Okay, and I think the interesting part is this dialogue system and speech understanding and dialogue management. So you can see just now, the algorithm is very simple. You just compare the keyword and give the answer. So it's a very simple, intelligent. Okay, so your robot actually, and you need to write a lot. You need to write a lot in order to achieve the intelligence for the robot to say to respond to the input. So if we can combine this dialogue anything to the robot, because you don't need to build your database, because the database will be very, very big database. So the robot able to recognize any open conversation. So you need a more powerful dialogue manager, which means you need to have a system to understand what kind of, you cannot write all the Q&A. Although I can tell you, most of the cases, even the online one, they actually have this Q&A set in order to, if they don't really do natural language processing most of the time or all the time. Okay, so I actually have a system that can let you do this thing without actually involve very complicated natural language processing. Over here, if you want to know, I have a system called AIML, artificial intelligence system, that can give you something. Oh, who is writing on the screen? Please don't do that. Right. So I can show you some system that you can actually do that in a dialogue system. So I actually quite like this system. So it's database that give you like how much 20,000 sets of Q&A and so on, and you can download a lot of new Q&A pairs, and it got the very flexible algorithm to actually understand similar questions. For example, like, what is your name? Please say your name, please, and so on, and how to categorize all the mechanism to do those kind of things. So if you combine all these things together, you're actually able to build a Google Home or whatever smart speaker. So smart speaker, I think it just contains all these modules. So you can actually customize your own speech smart speaker by putting all these things together. So all this content I will arrange, but I'm not going to do it like next week. Okay, so next week I will jump to the visual, find out the mechanism. If you are interested to know more, I'll show you how to do the vision system. Okay, so we will have the visual perception and we'll start that. But of course, vision 1 week is also too brief. Okay, we actually see like for the speech interaction, we have like at least now I have 2 additional classes I can give as an extension. And also for visual, I'm actually getting other speakers that know more things to do visual. So I will put all this in a different schedule. So we will run this as a basic in order for you, if you are interested to know more about speech interaction. Okay, please in the okay wait everyone. So please write if you're interested on speech interaction advanced class. Please indicate in this. Okay, don't do it in the chat. Okay, please write it in the Excel, the spreadsheet. Okay, please write in the spreadsheet in the remarks so that I can assemble enough people for the edit later on, so I can arrange. Okay, so if you're interested, yeah, just write there so that I know how many people, because I might invite other speakers to give the class as well. So I will do the arrangement of the schedule and also the rest of the things based on how many people I can assemble. Okay, so please write in the remarks if you're interested so that I can gather enough people to open the class later on. But next week I will jump to so I think I come to the end of this session. Okay, yeah, done. Right. So just good. I will stay for another 10 to 20 minutes if you have any question to ask, or else you can slowly log out. Right. Okay. So thank you, class. Thank you, everyone, and
excuse me, doctor.
See you next
I have
week.
a question. Hello.
Yes. Sorry, but I can't hear you clearly. So yes.
Can you hear me now? Hello.
Yes.
Yeah, actually, my question
I'm listening to
on the speech recognition. I want to do my robot go to bedroom, go to kitchen, so my robot can travel to the kitchen, to the bedroom, and then once the feedback that I am now here on your bedroom.
I don't know. So can you please type it out? Okay, to install the language model, the audio, can you please type it in the group chat? Yeah, because I really can't hear you clearly. So for you that you don't have any question, or for those that want to ask, yes, I will still be here. I saw it from Edmund. Is it Edmund or someone? Okay, if you want to hear, so no, not this. All right. So what you need to do from here, and you can check the folder, the voice file in this folder, but then download the voice file. Okay, you need to download the voice file, and then you need to extract the file, which is you need to uncompress it, and then you need to put the folder into this directory. Two are different. Okay, one is in the US directory, one is in the English directory. I don't know why they name it in that way. The Arctic Voices, so you can see like this one is the Arctic Voices. You need to add this into the end of the folder name, or else it won't work. That you put in, these are the folder or the voice that are female voices, right? Okay, so that is the answer. And yes, you need to make new directory for the pocket spin model because you don't have the folder, so you need to make the folder. I want to do a task to my robot to go to certain place, then the robot reach and give me feedback. I'm here to place. Yes. So over here, I'm only talking about speech. If you want to talk about navigation, maybe you need to wait for the class later. After the visual perception, then I will have the navigation. So in the navigation, I will show you how to make the robot able to do slam and also now. Okay, and from iPhone, I don't know who is this iPhone, but when we play a wave file, is it worth the whole to make a program to read? How long is it? I would suggest if you have specific file, you just use the sleep. If you want to use the unblocking, you can go to the tutorial, okay, that I show you the raw some sound play and define blocking and unblocking. But I don't really think it's easy to do. I can't really, how to say, I don't have time to show you here. But it is not so complicated. You just go to the ROS tutorial, I mean the sound play tutorial, and it will show you the blocking and unblocking thing. You just need to add one argument in your say. Okay, but I will suggest if you are not using this extensively and you don't worry that it will cause some problem with other things because you only have this alone, you can use the blocking method if you want. But if you are going to build a complicated system, sleep way maybe is more safe. I mean, will give you less problem. After that, just w@link admin, I'm not sure what you're asking. You're supposed to open the link, download the file one by one. Okay, you need to supposed to, yeah, you can't wget the link. Okay, you can't because it's a web interface that you need to hit you need to download it manually. Get the folder, then you put the content into the ENUS folder, just according to the slides. Okay, any more questions? Question, please. Any more things that you want to ask? Okay, if no more question, I'm going to end the session. Thank you, everyone, and I hope you can log out by now so that I can end the session. Edit corpus is to create your own database. Okay, you might have a new list of your database, like the set of instruction you want the robot to recognize and so on. So you edit the corpus and then you upload the corpus to the website, the CMU website, in order to generate the LM and DIC file and replace the original LM and DIC, the DIC and LM file in order for your recognizer to use the new database. So the corpus file is actually just a text file that contains all the sentences that you want the robot to recognize. Yes. So if you have no question to ask, I would appreciate you can log out so that I can end the session. Can you show the content of corpus file? Corpus file will look like this. For example, the LM one, the corpus file will look like this. Speech, RoboCup. Yeah, the corpus file look like lines with all the instructions that you want the robot to recognize. It's just a text file. If you don't like to name it corpus, you can name it other things. It doesn't matter, okay? But you need to know later on where you put your DIC and LM file, and you need to make sure that your launch file link to the correct path so that it can find the LM and DIC file in order for the operation, for the execution. So this is the file we need to create ourselves as our yes. For the assignment, yes, create your own database because that is part of the exercise so that you know how to create the database you want for your application later on. You might have your own data. So once you create the corpus, you need to generate the DIC and LM file. So you can use the website, the CMU website, to generate the LM and DIC file for your new database. Question? Okay, if no more, I need to close the session. Thank you very much. Okay. Thank you. Okay, thank you and see you next week. Bye. Stop sharing.